In this video, I will be showing you how to use gamengine2d, which is a Python package I created for kind of building game engines. And the core of it is Pygame. It's just kind of a wrapper for Pygame. So first of all, we're going to say pip install gamengine2d. I already have it installed. But while that's installing, I've created two files here, main.py and script.py. You'll see why we have script.py. But in main.py, we'll say from game engine 2D. We'll import star, just import everything for now. And then we have to actually create an agent. So we'll say, or create an engine. So we'll say engine equals engine, or you have to say from here. And then we'll create an engine, and then the engine will create a new window. So by default, the width of the window is 500. I'll set the width to be 1200. And then the height is also 500. I'll set it to 800. And then the name is game engine 2D. By default, the name of the window, I'll say name equals, or I can just leave it like that. And then resizable is true by default. So resizable just means that I can, well, like resize the window. It won't exactly, it is not the fixed width and height. But if I set that to false, then I won't be able to resize the window. So by default, it's true. And then you have the background color. So by default, this is color dot black, but you can say color dot blue. So color has, it has red, blue, black, cyan, green, and magenta. And you can say hex, color dot hex. It will take a hex string and convert it to the color. And you can say 2 hex. So you take the current color and convert it to hex, or you can say 2 RGB. And you also have white and yellow. So for now, I'll just say color dot black. I'll leave it as it is, or yeah, I'll just leave it as it is. And then if I just say engine dot run, you can see it takes two parameters, FPS. So it'll just try to match this FPS. It won't absolutely run at this FPS. It'll try to run at this FPS. By default, it's 60. And then dynamic view, that is basically, can I pan around or can I zoom in and out with the mouse? If that is false, then you won't be able to do that. But it's true by default. So if I go ahead and run this, I'll say Python main.py. So it will create a window here, and then I can pan around because I just have to left click and I can move my mouse. It should pan around. And then I can use my scroll wheel or the two-finger gesture on a touchpad to zoom in and out. Let's say you wanted to add a rectangle. So what you could do is you could say rectangle equals rectangle, and then you have to provide the position, which you can't provide a tuple. You have to say it's a vector 2D. And then let's say you want it at, so the coordinate system is in the middle of the window, that is 0 0. As you go towards the left, x increases, and as you go up, y increases. So if I say 100 100, and then I'll show the other arguments. First, I'll show you how the coordinate system is. So we'll say engine dot add object, and we'll add the rectangle. Now if I run this, you can see this would be the center, and we put it diagonally at like 45 degrees if anyways. So this is at the center of the object, not like the top left or whatever. The center of the object will be at whatever position you pass. And then next you have the size. So the size is also a vector 2D. You can say, right, by default it's 40 and 40. By default the position is 0 0. So you can say 100 and 200 for the size. And then the color, you can say color dot, you can say hex. So you can pass in a hex string, or you can say color dot, let's say blue. So this will generate a blue rectangle just like this. And then you have a rotation variable. So this is in degrees. So it will rotate counterclockwise that many degrees. So if I pass in like 50 degrees, it will rotate counterclockwise 50 degrees. And then you have visible. So by default, visible is true. And by default, rotation is also 0. So if visible is false, then you just won't see it. By default, it's true, but if it's false, then you just won't see the rectangle. And then finally, you have the name. So the name is just for you to be able to access this from other objects. I'll show you what I mean. So the name is by default just rectangle for a rectangle class, or yeah, rectangle class. But you can say like rect name equals rectangle, and then oh yeah, we have to set visible to true. Okay, so now let's say I want to add you have rectangle, you have a rectangle outline, like just the outline of the rectangle, and you have a circle, you have a polygon which you can have n number sides, and you have an ellipse, and you have a line also. So you can do whatever you want, you can mess around with all the arguments for those. But now let's say I don't want this rectangle to be just like static, I want it to actually be moving. So that's why we have script.py. In here, we have to say class script like this. Because if the file name is script.py, then the class name should be just the same thing. It should be the same thing but in uppercase. And then in the init, which is the constructor, we will take our object. So object, and it will take a context. So over here we can say rect.attach. So we can attach a script, and then we'll say script.py. And then it also takes a context. So we can just pass engine.context for now. For a default context, you can add your own context if you want. And then we can say self.object equals object, self.context equals context. So that's the constructor. And then there's one more required function, which is the update function, and that will take dt, which is delta time. So let's say you wanted to move the object left, or yeah, if you wanted to move it left by, let's say, 10 pixels per second, you could just say self.object.position dot x minus equals, you want 10 pixels per second, so 10 times dt. So you basically have access to the entire rectangle object here. When you attach a script, you have access to the entire thing. So you can change the position, the size, the rotation, the name, and whatever. You can even set it to be, you can set invisible to be false or whatever. Now if we run this, you can see the rectangle is slowly moving. And obviously you can change, you can say y, and then you can put like 100, so it'll move a bit faster, but in the y direction it'll move down. And you can change the rotation also. So I can say self dot object dot rotation plus equals, let's say I want it to rotate at 100 degrees per second, so I'll say times dt. So now it's rotating and it's moving down. Next, let's say you have, let's say you want to, let's say you have actually, let's say you have a another rectangle. So I can say rectangle 2 equals another rectangle, and then the position is vector 2d. We'll say like something like negative 400 in the x and 0 in the y. And now if we say engine.add rect2, so we'll say this over here too. And then over here in the script.py, we can just remove this, and we can also import keyboard, or yeah, we can say pip install keyboard, and I already have it installed again. And then up here we'll say import keyboard, and then we can say if keyboard dot is pressed. So if I press the left arrow key, I want to move the object left. So I can say self dot object dot position dot x. So if I increment x, or if I increase it, it will go more to the left. So I'll say plus equals. And over here I can also define self dot object, or self dot speed will be, let's say, 100 pixels per second. So plus equals self dot speed, and if it's per second, we have to multiply it by dt. And we'll say if keyboard dot is press, if we press right, it's the same thing, minus equals. And if keyboard dot is press, if we press up, so we want to increment y, and the same thing for down, so we just want to decrement y. So now we should be able to move the blue rectangle. Okay, so it's actually mix these up. It should be, if we want to go left, it should be minus because x decreases. If x decreases, we go left. Now if I were to run this, you can see we have this here, and accidentally reversed y also. Y was proper. So now if you can see here that I'm moving the rectangle with my arrow keys. And then let's say I want to check whether the rectangle is touching this second rectangle, right? So if I want to check for that, I'll create a new function, def check collision. And then I can just say if self dot object dot, or yeah, I can say if self dot context dot object, or no, if self dot context dot functions. So by default, the engine has functions in its context. So for functions, you have draw sphere and you have draw text, and you also have is colliding. So we'll check is colliding. So this function will only work if both of the objects are not spheres. So in self.context.functions.is colliding, you have to pass the self.object, and you also have to pass the name of the object you want to check if it's colliding with. So over here, we named this rectangle. Let's name it name equals rect2. So while creating it, we set the name, and then over here, I'll pass in rect2. And then actually, we don't even need this if statement. We can just say, we can return this. And then over here, if I in the update function, after this, we can say if self dot, or after setting the position, we can say if self dot check collision. So if we are colliding, then we'll say self dot object dot position dot x plus equals self dot dt. So if we are colliding, then we'll just go back to when we weren't colliding. And then same thing for this. So I'll just copy this, and then instead of this, I'll say x minus equals, and then over here I'll say if self dot check collision. So if we are colliding, then we'll just reverse whatever we did before. And then I'll just change this sign to plus. So now if we run this, you can see here I can still move, but it's why if I intersect, you can see I stop moving. If I go down, basically if I collide with the object, I stop moving. Or if I collide with the object, I don't stop moving, I just can't go inside the object. I can move away from the object, but I can't go inside it. And that's it for this video. In the next video, I'll be showing you how to make another game, which is Space Invaders. And yeah, that's it for this video. Okay, bye.